Alright, in this segment we're going to be taking a look at collision detection. So collision detection is essentially a means for you to detect that two objects have touched one another. And so an example of what collision detection might look like is I'll take a cube and a sphere. And let's say that I wanted the two of these objects to know that they successfully touched one another. So in other words, if I were to take the two shapes and smash them into each other, the two objects should be able to have some sort of way of knowing that that interaction happened. One of the reasons why this is important is we've already discussed how using getComponent is essential for having objects being able to talk to one another. But one of the drawbacks of just using getComponent by itself is the fact that you need to link up GameObject references in the inspector. Sometimes you don't have the luxury of being able to link up objects in the inspector, especially for objects that are created dynamically at runtime. Things like bullets, lasers, rockets, all those sorts of things. Things that are intended to collide with objects, but don't necessarily exist in the scene prior to the game starting. So let's go ahead and take a look at how objects can gain reference to one another by virtue of touch. So the first thing that you need to establish is you need to figure out which object you want to know about the interaction, which object you want to know that it was just touched. So let's say that I want the cube, for example, to detect that it was the thing that was touched. So what after I've decided which objects need to be capable of detecting that something touched them, the next thing I need to do is make sure that all of the objects that are participating in the collision have at least a collider component associated with them. So here you can see that I have my sphere. My sphere has a sphere collider. My cube has a cube collider. So they're already ready to go. Next thing is whichever object I want to detect the collision, I'm going to need to attach a special component, which is called the rigid body component. And so I'm just going to go add component, rigid body. Now, something that you have to be careful about with rigid bodies is, let's say I were to run my game now. So I'm going to press play. After you attach a rigid body component to something, that means that it's controlled by the physics engine. So the physics engine does all sorts of really cool, interesting physics things. One of the things that it does is gravity. And so by virtue of adding the rigid body component, you basically say an object is now under control by the physics engine. And one of the side effects that we don't want from that in this particular example is we don't want to use gravity. So I'm just going to disable gravity. I'll go ahead and press play, and cool. That's exactly what we're expecting. No objects falling or whatever. So I'm going to go ahead and create a new script. And let's assume that this is just called player. So I'll go ahead and double click to open up the player script. Cool. So here's our player script. So now that I'm inside of my player script, the next thing that I need to do is I need to introduce an additional, what we call a callback, which is a special kind of function that gets called whenever something special happens inside of Unity. So start is a callback that happens whenever the game is started or whenever this object comes into existence. Update is a callback that gets called all the time. The next callback I'm going to introduce, and this is one of the more difficult looking callbacks, especially thus far, is void on collision enter. It's really important that you type that out correctly. If any part of this is not correct, if you don't have certain letters capitalized, and if any part of this is not exactly as I have it written here, it's not going to work. Next up, we're going to have an open parenthesis, and with this, we need to provide a collision other object. And so you can think of items that exist inside of these parentheses as sort of like ingredients. And so these ingredients are basically, they're different elements that are required to make a function, to allow a function to do what it needs to do to get its job done. So in this case, on collision enter needs, in order for it to do its job, it needs to be provided with the object that just touched it. So what I'm going to do is I'm going to simply output the name of the object that made collision with the player. So I'm simply going to type in other.gameObject.name. And so what I aim to do with this is simply print it out to the console. So I will wrap that up in a print command, like so. Cool, so I'll go ahead and save that. and minimize. And I'll attach that to my cube. And I'm going to split my view here so that I have my game view and my scene view kind of side by side. The reason I'm doing that is because I don't want to write some sort of elaborate character controller for the purpose of just testing this thing out. I kind of want to keep everything as simple as possible. So I'm just going to manually be colliding these objects over here in the scene view. So I'll go ahead and press play. And then I'll just divert my attention over here to the scene view. And I'm going to grab this sphere and I'm just going to bump it into the cube. So I'm just going to bump into it. And you can see here that it says that it was able to detect that the sphere collided with my cube. Let me go ahead and run through this again. Let me just clear that up. So I'll just take my my sphere and I'll simply just bump it into my cube. So I just have to be a little bit soft with it, just simply because I'm moving it manually, and so this is not how normal collision detection will work. It's just a really fast demonstration, just to get the point across. But you can see that it is indeed capable of detecting that I have intersected with the cube, and since it does not utilize gravity, which would be its the downward force, if I bump into it and take it off axis, it'll start to do this weird zero G floating kind of thing. So that's one of the simplest ways that we can detect collision between objects, is simply by setting up these parameters and just running through this a real quick demonstration like this. So that is just simply one form of collision detection. The other form of collision detection that we're going to talk about really quickly is a little bit different. It is actually very, very similar. It only differs in two things. One, its name, and two, in precisely how it behaves. So the next thing we're going to talk about is triggers. So let's say that I wanted to convert this cube into a trigger. So let's say that this player is going to become a trigger. The difference between a trigger and a normal colliding entity is the fact that a trigger does not have these physical properties that resist motion. Or so you can see, like with this example, how I can take my sphere and I can kind of push it into my cube, and I can move my cube by virtue of just pushing it around. That's because this thing has these physical properties. It basically tries to keep entities from intersecting with one another. But let's say that I wanted to have collision that was entirely based on objects intersecting with one another. What I can do is I can simply change the collider type to be a trigger. So when an object is a trigger, you can no longer move it around simply by pushing objects into it. Triggers are typically not visible. So if you were constructing a trigger, you would probably want to disable the mesh renderer on it. So here I'll just do something like this. So if you've ever played a game where you've realized that after you enter a certain zone that a bunch of stuff starts happening, you've most likely entered into a trigger. And so unbeknownst to you, you just kind of meandered into this trigger. And after entering that trigger, some sort of code got launched just because you entered that volume. So how do you go about setting up a trigger? In order to set up a trigger, all you have to do is slightly modify our existing code. So instead of doing on collision enter, you can do on trigger enter. And the trigger enter callback does not take a collision object, it takes a collider object, which is just slightly different. And now everything will work just like it did before. So if I go ahead and save this and minimize it, for the purpose of this demo, I'll go back to the cube and I'll re-enable its mesh renderer just so you can see it. And I'll go ahead and press play. And if I take this cube, you can see that on trigger enter is indeed working. Let me clear the log just to make sure, and I'll pass into it again, and you can see that I am once again detecting collision. So when will you use one over the other? The answer to that is usually pretty straightforward. If you need for objects to actually bump into one another and actually prevent each other, repel each other from entering each other's space, then that's when you want to use normal, just standard physics-based collision detection. If you are wanting to detect that objects have entered one another, but you don't actually want to separate those two objects, you don't want for them to, to try to push each other apart or anything like that, then going the trigger route is most likely going to be the best option for you.